This is Geometry, Unit 7. We're working on similar triangles. What we want to check on is what must be true about angles and sides for two triangles to be similar. Well, we're going to look at it as the corresponding angles are congruent and the corresponding sides are proportional. So what that would mean is if you had your pictures drawn, like maybe it would be 3, 4, 5, and then you would have 6, 8, 10. So the sides are proportional. They're 2 times as much as the other. The angles would also have to be the same. And that's what makes triangles similar. Their angles are congruent and their sides are proportional. Now that's actually 6 things we're looking at. All 3 angles and all 3 sides. There are some shortcuts. One of the shortcuts is called angle-angle similarity. So what must be true to prove triangles similar by angle-angle similarity? All we have to do is look at the corresponding sides. We're looking at 2 sets of corresponding sides. And I just said corresponding sides, but the AA refers to angles. So we're looking at 2 sets of corresponding angles are congruent. The angles must be congruent. So some real common pictures to draw might be something like this, where you could have parallel lines and you have corresponding angles, and then you have your reflexive angle up at the top. That would be enough to show that the small triangle and the large triangle are proportional. Or the terminology is the 2 triangles are similar. Another shortcut method is to use SSS similarity. What must be true to prove 2 triangles similar by SSS? The corresponding sides are proportional. So in this case, we're not looking at any angles whatsoever. We don't have any angle information. We're only noticing that the sides have a common scale factor. Kind of like my first picture I had up here, where the 3 was times 2 to get to the 6, the 4 was times 2 to get to the 8, the 5 was times 2 to get to the 10. What must be true to prove 2 triangles similar by SAS? So these are 2 sets of sides are proportional and the included angles are congruent. And the included, that's the one that's in between the 2 sides. The included angles are congruent. Remember, angles are congruent, sides are proportional. So what that might mean if we know that this is 3 and this is 2 times that amount, this is 4 and this is 2 times that amount, this here might be 60 degrees and this here might be 60 degrees. So we have corresponding sides that are proportional, and we have the included angle of those sides that are congruent. Determine if these triangles are similar. We need to identify the scale factor and write a similarity statement. So what we're going to look at, since we don't know what the similarity statement is, we don't know what sides necessarily correspond to each other, we can look at the smaller side and compare that to the smaller side. So those two have to be corresponding to each other. So that is 2 to 3. And then we're going to compare the medium side with the medium side. And that's going to be 3 to 4.5. Now that's kind of tough to simplify. One way we can do that is to times them both by 10. That's to get rid of the decimal. Now we don't have a decimal. Now we can divide both of those by 15. 15 goes into 30 twice. 15 goes into 45 3 times. And there we have the scale factor the same. Alright, and then we would also want to check on the longest side. We're looking at BC. We're looking at RI. That is 4.2. That is 6.3. Okay, I'm not sure what numbers are going to go into those evenly, but if I times it by 10, I can get 42. And I can get 63, and there we may notice a couple things go into it, but something you may notice at first is that 7 could go into there. It goes in there 6 times, it goes in there 9 times. Then you notice again that 3 goes into there, so you don't have to find the biggest number necessarily, you just have to keep reducing it. So what that tells us is that 21 actually went into both. So we have all 3 sets of sides being proportional. We have enough information for that. So now my triangle BAC, I can name that first triangle in any order I want. So I went down the small side, down the medium side, and then back down the longer side. So small, medium, and large. So that's got to be RTI. And the theorem that we used was side, side, side similarity. So we showed that the triangles were similar because their corresponding sides had the same scale factor. We had our similarity statement and the reason for why the triangles are similar. Here we're going to reduce, but notice how the units are different. The units need to be the same, so you could either change the yards into feet, or you could change the feet into yards. There are 3 feet in every yard. So here we have 3 yards, 27 feet. Well, 3 feet makes 1 yard, and 3 goes into there 9 times. So there are 9 yards. Now we can reduce that by dividing them both by 3. Now they have the same units. We can say 1 yard is to 3 yards. Here we have 42 inches and 12 feet. we can convert that to the same scale factor, same units. We could make them both inches, we could make them both feet. You can go either way. Since this is not a perfect feet, it's not divisible by 12 evenly, I'm going to suggest that we convert the feet into inches. So 12 feet. 12 feet, we know each foot is 12 inches, so 12 times 12 is 144. Now we can start trying to figure out some items that would go into these. Well, 2 obviously goes into both of them. So 2 goes into this. And 2 goes into this guy. Okay, well, 3 can fit into both of those. And that means 3 goes into 21 7 times. 3 goes into 7 twice with 1 left over. 3 goes into there. So that's what our scale factor, this would be reduced. 7 inches to 12 inches. Or, sorry, 24 inches, which would really be 7 inches to 2 feet. But to do our reducing, they have to be in the same units. You cannot just work with the 42 and the 12. Here we have seconds and minutes. We know that there are 60 seconds in a minute. So $60, of course, doesn't go into 100 evenly. So we can't convert this evenly into minutes, but we can convert this evenly into seconds. There are 60 seconds in a minute, and there are 7 minutes. So you have 100 seconds over 7 times 60, which is 630 seconds. And 10 goes into both of those numbers. And there we see that 10 seconds to 63 seconds would be our reduced format. Explain why 2 equilateral triangles are always similar. For us to have equilateral triangles, we know that the sides have to be the same. Now, between the 2 triangles, one triangle can be bigger than the other, but this is equilateral and that's equilateral. Well, to be equilateral, then you know you're going to be 60, 60, 60, which is going to make these all 60, 60, 60, because 180 divided by 3 is 60. An equilateral triangle has to have all equal angles. So we reduce this down to 2/3 as a scale factor. So, explain why. The corresponding angles are congruent. They happen to all be 60. The corresponding sides have the same scale factor, which means the corresponding sides are all going to be 2 to 3. 2 right triangles are not always similar. Well, if you have a right triangle, maybe it would be a 3, 4, 5. And then you could have another right triangle. Maybe that would be 3, 3. Alright, you have to be a little strategic with how to figure out your other side, but that we'll learn in other lessons is going to be 3 root 2. You could figure that out by Pythagorean theorem. A squared plus b squared equals c squared. So when we look at the scale factors, the corresponding sides are not proportional. They don't have to be proportional. Also, just because 2 triangles have a right angle, they're right triangles, the other angles do not have to be congruent. So 2 right triangles are not always similar. Explain why that happens. Well, the corresponding sides are not always proportional. And also the corresponding angles besides the 90, I guess you could say the acute corresponding angles, aren't required to be the same. Next, we're going to look at a stop sign. 2 stop signs are always similar. Well, here's a little picture of our stop sign. Our stop sign has 8 sides on it. We learned some ideas about polygons in the past. We learned a little formula, if you recall. We learned about n minus 2 times 180. So if we take our 8 minus 2 times 180, so 6 times 180, timesing that by 6, 48, we got 1080. So all the interior angles of a stop sign add up to 1080. In a stop sign, it's actually a regular polygon, and that means they are all congruent to each other. So if we divide them by 8, 8 goes into 10 one time with 2 left over. 8 goes into 28 3 times with 4 left over. 8 goes into 40 5 times. So each angle of a stop sign has to be 135 degrees. They're all congruent. That has nothing to do with sides. So the angles are congruent all the way around, but the sides themselves are also going to be the same length. A stop sign is a regular polygon, and a regular polygon has all equal sides and all equal angles. We calculated what the angles were for all stop signs. The size of the stop sign might change the length of a side. Therefore, you get 2 similar stop signs. So, explain why 2 stop signs are always similar. Stop signs are regular octagons. So, let's say, therefore, corresponding angles will be congruent. Now remember, this isn't a triangle. We can't stop there. We actually have to do all the angles and all the sides. and the corresponding sides will have the same scale factor. Here's a stop sign, and the angles are 135 degrees. That's what would make it work its way around and have exactly 1080 degrees inside. But the side lengths are different than the stop sign you might see out on the street. The stop sign on the street is going to be much longer, maybe 6 inches, 10 inches. Here, about a half an inch. So you can tell that the scale factor will be the same for each corresponding set of sides.